to those of you in the United States. Perhaps good evening to others of you as well. Thanks for joining our live stream today. Today's online lecture is presented by the National Capital Area Skeptics, NCAS, also known as NCAS. I'm Scott Snell, NCAS president, speaking to you from my home in Greenbelt, Maryland, just outside of Washington, D.C. NCAS serves the D.C., Maryland, and Virginia area and online as advocates for science and reason. We promote the scientific method, rational inquiry, and education. Find out more about us at ncas.org and also have a look at our collection of past NCAS lectures on our YouTube site. You'll find interesting lectures on topics such as Scientology, how to read a medical study, and how to scientifically investigate ghost stories. That was our talk last month. NCAS has been hosting our monthly public lectures since our founding in 1987. Usually we host lectures in Maryland, Northern Virginia, and events in DC, but for the time being, we'll continue our monthly lecture series online. Now, before I introduce our speaker, here's a quick run through on how we'll handle our questions and answers session today. To the right of your video display, you'll see a chat window. Please post your questions there. You have to sign into a Google account in order to post. Include the name of your city or town and post your questions anytime. Our speaker will answer them after he finishes his presentation. It's my pleasure to introduce Paul Halpern, a professor of physics at the University of the Sciences in Philadelphia. He's the recipient of a Guggenheim Fellowship and a Fulbright Scholarship, and is a fellow of the American Physical Society. He's author of 16 popular science books, including The Quantum Labyrinth, How Richard Feynman and John Wheeler Revolutionized Time and Reality, and his new book, Synchronicity, The Epic Quest to Understand the Quantum Nature of Cause and Effect, which he'll be discussing today. Joining us from his office in Philadelphia, ladies and gentlemen, Dr. Paul Halpern.
Thank you. I'd like to thank Scott for the kind introduction and thank NCAS for inviting me here. I'm going to be talking today about my book, Synchronicity, as mentioned. So my book is a bit about connections between physics and psychology. I'm going to start off my talk with a very famous physicist, who I'm sure you've heard of, Albert Einstein. He's famous as being the father of relativity, including special relativity involving high speeds and general relativity involving gravity, but also he is one of the fathers of the quantum revolution, the idea that energy is made of small parcels, and that started more than about 120 years ago in 1900, and Einstein's contribution took place in around 1905 with what is called the photoelectric effect, which is the idea that light comes in tiny parcels of energy, and if you shine a light on a metal, you can excite the metal and create electricity in the metal. That's the photoelectric effect. And we're using that effect all the time in modern cameras, digital cameras, cell phone cameras, all make use of Einstein's contribution to quantum physics. Now, surprisingly, Einstein, at a certain point in the 1920s, began to doubt quantum physics. So even though he was one of the people behind quantum physics, he began to become skeptical about quantum physics in its current form. And for example, he once told quantum physicist Max Born, "Quantum mechanics is very worthy of respect, but an inner voice tells me that it is not the genuine article after all. The theory delivers much, but does not really bring us any closer to the secret of the old one," meaning Einstein's concept of nature, which he equated with the divine. I am convinced that he does not play dice. So sometimes that's summarized as God does not play dice. And that was one of Einstein's first critiques of quantum mechanics. As quantum mechanics developed in the 1920s, it became dependent on the idea of chance there were rules, but the rules were known only probabilistically, not exactly. Einstein believed that the universe must be deterministic, meaning one event must follow from the previous event, kind of like falling dominoes. And that's not exactly how quantum mechanics works. So Einstein based his idea on a philosopher named Baruch Spinoza, a Dutch Jewish philosopher, who said, in nature, there's nothing contingent, but all things have been determined from the necessity of the divine nature to exist and produce an effect in a certain way. So Spinoza felt that the divine was constrained to certain rules, meaning the universe followed certain rules, and those rules followed one after another, and there was no chance at all involved. And that's where Einstein got his concept of a kind of a scientific deity. And he once said that his views of religion were very close to that of Spinoza, admiring the simplicity of nature and the natural order. The Clockwork Universe is something that dates back well before Einstein, dates back to the work of Isaac Newton. Isaac Newton's laws, very simple laws of motion, tell us how the universe functions. And they say that if you know all the particles in space, all the objects in space, you know the forces on those particles, you should be able to predict the future of the entire universe. Kind of like winding up a clock, and the clock just works, it functions, it keeps ticking and ticking and ticking. And all you have to do is start it up and everything should proceed from there. That was Einstein's vision of the universe. Unfortunately, for Einstein, that's not exactly how quantum mechanics works. Quantum mechanics has these chance elements, so you can't exactly predict the whole future of the universe using quantum mechanics. Now, another critique Einstein had of quantum mechanics has to do with the idea of quantum entanglement. Quantum entanglement says that you can take two particles, separate them widely, and measure a property of one of the particles, and you immediately know that same property of the other particle. So you immediately know what the reading would be of that particular property. For example, how the particle reacts to a magnet. If you measure one particle's reaction, you immediately know the other particle's reaction to a magnet. And that's very strange because, first of all, it's a long distance effect. And secondly, the question is, how does a second particle know exactly what you're about to measure? Einstein felt that objects should have predetermined properties that have nothing to do with measurement and should only change because of their environment, their local environment. If something affects an object immediately, one of its neighbors, then an object can change. Not something that's far afield, not something that's separated by a huge distance. And certainly that property should not depend on somebody making an observation. And that's called local realism. That was Einstein's view. And he called entanglement famously spooky action at a distance. And it's funny that he used the term spooky because Einstein often had encounters, especially during his years in Southern California. He often had encounters with so-called psychics. He had a friend named Upton Sinclair, who was a well-known writer, who had an interest in mediums and so-called psychics. Einstein didn't believe in any of that stuff, but he felt like he had to address that. And then when quantum mechanics came along, he started to feel that it seemed too much like the supernatural. Even though it wasn't the supernatural, it seemed to behave in a way that wasn't really scientific, but seemed rather spooky. In 1935, Einstein and his two assistants, Podolsky and Rosen, produced a paper called the famous EPR paper, which critiqued quantum mechanics because it wasn't locally realistic, because it had action over a distance, and or seemed to have that. And famously in the New York Times, there was a headline, Einstein attacks quantum theory. He finds that it's not complete, even though it's correct, that it's only part of reality. And indeed, Einstein was working on, at the time, a unified theory of nature that would explain all of reality, and it would include quantum physics as a possible repercussion of that major theory. So Einstein was hoping to supersede quantum mechanics and not to erase it, not to negate it, but rather to build something new that was deterministic, that included quantum mechanics as one of its components. Now let's turn now to psychology. A little bit of an abrupt shift here, but psychology has its own believers in determinism. For example, Sigmund Freud felt that the early childhood determined the adult life, that events that happen to children affect them for life and are somehow buried. And that sometimes when you dream or when you make a slip of the tongue, that reveals something that is buried from childhood. So that's a way to get at the causes of these effects. So like Einstein, he believed in a chain of causality. So if something happens now, it must have been caused by something in the past. So here's a cartoon about Freudian slips. A Freudian slip is when you say one thing, but mean your mother. I mean another. So it's if you talk about something and you say the wrong word, Freud thought that that was often revealing of something that's happening in childhood. So in the Freudian picture, the unconscious mind is what stores all that information from the past. The conscious mind is only the tip of the iceberg, but things flow upward from the unconscious mind. This has not strictly been tested scientifically. This is just a conjecture. Now let's turn to two rebels, a physicist who rebelled against Einsteinian deterministic physics, and a psychologist who rebelled against Freudian deterministic psychology. Wolfgang Pauli, it's pronounced Pauli because he was from Vienna, that's the German pronunciation, was a quantum physicist. Sometimes, because of his brilliance, he would be known as the second Einstein, which in German would be Schreistein, which means literally two stone instead of one stone for Einstein. Carl Jung was a psychoanalyst, and unlike Freud, he didn't believe in strict determinism from the past, but rather he believed in something called a collective unconscious, that things that happen to other people or even to other people in the past can affect you, because the unconscious mind is not centered on the individual, but transcends the individual. It's something that embraces all of humanity, as a matter of fact. And that when you have images in your dreams, for example, an image of a woman or image of a man, those are archetypes of things that might have happened to other people in the past, maybe even in ancient Egypt. And these are symbols that have persisted throughout the human race. Jung was not exactly sure how these symbols spread from person to person, but imagined somehow that there was a kind of inheritance of these archetypes, and that because of this inheritance, that we have access to a collective unconscious which embraces the entire human race. Now, around 1930, Jung coined the term synchronicity, and this was in reaction to two things. It was in reaction to his reading of a book called the I Ching, Chinese book of divination, and also to modern physics, the idea in general relativity that things can be connected both in space and time in a way that we would not anticipate, in a way in which causes can affect the past as well as the future. Now, Einstein and Jung had several dinners together when Einstein was working at Zurich, at the University of Zurich, and at a university called the ETH in Zurich in the early 1910s. And these dinners led Jung to an appreciation of the idea of flexible time and space in general relativity, and a thought of connections that are acausal, that do not obey the law of cause and effect, which generally operates slower than light. So cause and effect generally takes place at a rate that's at light speed or less, usually less than light speed. For example, a sound wave is much, much slower than light. So that if you say something and somebody else reacts, that reaction takes place much slower than light. And Jung felt that there are also acausal connections that transcend the speed of light. So he connected this later with the idea of entanglement, that things can happen non-locally, that causality is not the only principle in nature. Now, Wolfgang Pauli was a very hard-headed physicist. He was very strict about his physics, and he was known as being extremely bright, a genius, but also very critical of other physicists. So if somebody was giving a seminar, Pauli would inevitably find critiques of that seminar, and he would blast the speaker during the question and answer session. And so speakers would tremble at what he might say to them. Similarly, if somebody handed Pauli a paper, he would be able to find the flaws in the paper. Even Einstein would hand Pauli its papers on unified field theory, and Pauli would come up with devastating criticism. And at least at one point, Einstein said, "You were right after all, you rascal," because Einstein realized he was wrong and Pauli was right. So Pauli was brilliant enough to be able to find errors in Einstein's thinking, which is pretty amazing. And one of Pauli's famous put downs was that a theory was so incorrect that it was not even wrong. And a blogger and physicist, Peter White, has adopted that as the title of a blog and a book, Not Even Wrong, things that are so silly that are not even worth looking at. What Pauli was famous for was primarily two things, although he made a number of contributions to physics. The first thing he was famous for was a particle called a neutrino, which is a lightweight particle that's produced all the time in the universe. We're being bathed in neutrinos all the time from the sun because they carry energy, but they're so lightweight and so hard to interact with other particles that millions, billions of neutrinos can pass through us all the time without interacting. So we don't even feel them passing through. So if you want to scare someone someday, you can tell them that they're bathed in neutrino radiation and people will think that's something serious, but actually it's something completely innocuous that happens all the time. The Pauli exclusion principle is what actually got him the Nobel Prize in 1945, which is the idea that any two particles of matter, such as electrons, can't be in exactly the same quantum state. They can't have exactly the same properties. There must be something different about them. So quantum state is like the name, rank, and serial number for quantum particles. It's the information they give out. If you probe them, you ask them what state they're in, and they give you several bits of information. But you can't have two particles saying exactly the same things. They have to be distinguishable. So if two particles had exactly the same energy, exactly the same angular momentum, which is a property having to do with rotation, then there must be something different. And the difference is a quality called spin, which says that relative to a magnet, if one particle is facing one way relative to the magnet, the other particle must have its axis in the opposite direction. So it must be counteraligned with the first particle. And that's the exclusion principle. And that is why atoms, one of the reasons why atoms are stable is because their lowest states have to have this difference. And because of this difference, other electrons must be even more different. And another way for other electrons to be even more different is to have different energies as well as different spins. So they all occupy different seats in the quantum arrangement of electrons around an atom. So it's a bit like stadium seating. Matter particles have to sit in their own seats, and they have to separate, and they can't all cluster into the same space, like energy particles. Energy particles can cluster kind of like in a concert, a mosh pit where everybody's grouped together at a punk rock concert. Well, matter particles are much more polite than that. They sit in their own seats, kind of like attending a classical concert where everybody is very polite and separates one seat to another. And one way two particles can separate is by having opposite spins. Now, Pauli was very sensitive, and around 1927, his mother committed suicide after his father had an extramarital affair, and that was devastating to him. And he was became interested in shortly thereafter in a woman who was a cabaret dancer. There was more of a physical attraction, and they were married only a year because she had fallen in love with a chemist and didn't break up with the chemist and hardly saw him during the year when they were married. And Pauli was so cynical about that. He said, had she taken a bullfighter, I would have understood, but such an ordinary chemist. And around that time, he began heavily drinking, and he was very upset. And finally, his father said, look, you need to go for therapy. So he wrote to Carl Jung, who was in the same city, for therapeutic advice. And Jung said, well, what's your problem? And Pauli said, women. And Jung said, okay, why don't you see my young female assistant who's training in psychotherapy, Erna Rosenbaum, and she can help you. So Pauli went for therapy with Erna Rosenbaum, and she instructed him to write down his dreams every night. And he wrote down hundreds and hundreds and hundreds of dreams, more than 1,000 dreams in all. And she conveyed them to Jung, and she taught him to self-analyze, to analyze his own dreams using the Jungian philosophy. So he ended up sharing more than 1,000 dreams with Jung, all in all, full of symbolism. This is a picture from one of his dreams called the world clock. And notice 4 figures. The number 4 was very significant to Jung, to Pauli and Jung, because of the symbolism of it. And they're rotating around a dial, and that's on a bird, and then there's another dial. So these all had a kind of symbolism according to the idea of Jungian archetypes. So soon after this self-therapy and the therapy with Rosenbaum, and then later some sessions with Jung, Pauli was healed. He drank less, and then he fell in love with Franca Bertram, and they got married in 1933. And kind of interestingly, if you look at the picture of young Pauli with his mother, and then middle-aged Pauli with Franca, it's kind of interesting, the similarities there. I don't know what Freud would say about that, or Jung. So in the late 1940s, Pauli and Jung began more of a scholarly collaboration. They began to explore Jung's idea of synchronicity as an acausal connecting principle. And then around that time, Pauli also became interested in the work of 2 astronomers/astrologers, Johannes Kepler and Robert Fludd, who worked in the early 17th century, and they looked at models of the universe and tried to come up with connections between models of the planets and ideas in astrology, ideas in divine teachings, and so forth. They had very different views. Now, Kepler went on to develop a successful model of the planets that was based on science. But Pauli was interested in some of the less scientific works of Kepler and Fludd and comparing the two. and looking at them through a Jungian analysis. He also began to look at symmetry as being an essential feature in physics. Well, of course, you have spin up balanced by spin down, as we mentioned, but there are a lot of things in physics that are based on symmetry. And he linked it to ideas in ancient Greek writings, such as the Pythagoreans, the yin and yang symbol, and so forth. He was very interested in Eastern mysticism. So, for example, in Pythagorean ideas, this is a symbol called a tetrachist, which is 4 rows, and they represent the numbers 1, 2, 3, 4, and they add up to 10. And in Pythagorean numerology, 4 has a significance, 2 has a significance, and 10 has a significance of being the number that represents everything. Now, Pythagorean numerology, like most ideas in numerology, has sometimes happens to have correct predictions, and other times is splendidly wrong. So, for example, the Pythagoreans predicted that the musical scale would sound very nice, and it does. You know, modern music sounds amazing because of the frequency differences that the Pythagoreans came up with. But also the Pythagoreans predicted that there were 10 objects in celestial objects in space, including a 10th planet called the counter Earth that was always on the far side of a central fire. And as far as we know, that doesn't exist. So here's another object from Kepler. This is also based on numerology. These are platonic solids. You have a pyramid inside a cube, inside, normally it'd be nested in other objects. And he wanted to use this to represent the planets. Kepler did, but that never quite worked out. So once again, ideas of symmetry, ideas of elegance of numbers, sometimes they yield important information if you test them scientifically. Other times they are spurious results and have nothing to do with science. So once you come up with such ideas, not that it's bad to come up with theories based upon symmetry and beauty. Sometimes that works out, but sometimes it doesn't. So you need to let it go if experiment proves you wrong. And that's what Kepler eventually had to do, because he found out the planets move in elliptical orbits, not spherical or circular orbits. And then, as mentioned, Pauli was also interested in the work of Robert Fludd, which he interpreted using Jungian symbolism and the yin-yang symbol. So let me talk a little bit more specifically about quantum entanglement. So quantum entanglement means that if 2 electrons are prepared such that one is, they're in the same quantum state except for spin, you know that one of them must be spin up and the other must be spin down. Well, suppose you don't even observe these objects, and you then you separate them, and you don't observe them until they're widely separated. You observe one of them as spin up, the other one is automatically spin down, and that's quantum entanglement, no matter how far they're separated. Now, Einstein called that spooky action. Pauli thought that's the fundamental truth that acausal connections do exist in nature, and they're possible through symmetry. The fact that they must be balanced up and down, no matter how far away they are, that's a fundamental truth in the universe. It's just as fundamental as the law of cause and effect. So Pauli saw that as a fundamental truth. Acausal connections are just as important as causal connections. Now, does this information travel faster than light? Well, that's an open question, but it doesn't necessarily have to travel faster than light if the quantum state contains a large distance. It would just be a single quantum state that contains a wide range of space. So the information doesn't have to travel, it's just there somehow. So Jung and Pauli wrote a book together with 2 parts. One part was about Pauli's ideas about Kepler and Fludd, and the other part was Jung's concept of synchronicity, which Pauli helped out with. But in particular, Pauli helped Jung develop this diagram. Now, I mentioned the number 4. 4 is really important, both in mysticism, such as to the Pythagoreans, also in physics. Number 4 is important. Well, they developed a diagram that has 4 quantities that are connected in pairs. So 2 pairs make the number 4. And the pairs are energy versus space and time. That's something that comes about through relativity. So that's something most scientists would say is true. And then causality balanced by synchronicity. So cause and effect balanced by these spooky acausal connections. Now, much of synchronicity, I should say, has to do with a kind of pseudoscientific idea that coincidences happen in real life. Now, Jung thought that that was the case. For example, one time, one of his patients dreamed of a golden scarab, and Jung happened to see a beetle in the window and connected the two and said, wow, what a coincidence. My patient dreamed about a scarab and I just saw a beetle. Well, what Jung didn't do is use statistics to analyze what are the chances that something like that would ever happen. Well, apparently this just happened to Jung once because he talked about it once. It's not happening every day. So the chances that sometime in life you would talk about something and then you see the actual thing or something close to the actual thing is pretty high if you think about it seriously. So it's probable, it's not unlikely, but rather probable that sometime in your life you would have a vivid dream about something and then have something similar happen to you or someone else in real life, just by sheer chance. So when one looks at coincidences, one has to rule out the effects of large numbers and sheer chance. Now, one thing that Pauli thought was connected with synchronicity is something called the Pauli Effect, which is a penchant for Pauli's penchant for being able to walk into a lab, any lab, and equipment would immediately be destroyed. He wouldn't even have to do anything. Delicate devices would somehow fail. That was the Pauli Effect. And he began to think there was an acausal connection between these accidents. For example, one time he was not even in a lab. He was in a train station in Göttingen, Germany, and suddenly equipment at the university there exploded for no reason. And it was alleged that that was connected with him being in the town. Another time he was visiting Princeton, something similar happened. He was in one side of town and a cyclotron caught on fire in another part of town. Cyclotron is a particle smasher, and it burned for more than 6 hours and blackened the walls of the building. Eventually that had to be removed. Now, in April 1948, Jung opened the C.G. Jung Institute near Zurich on a beautiful lake in the village of Kusnach. And Pauli was invited to attend the opening ceremony. At the opening ceremony, all of a sudden, there was a loud crash. A beautiful Chinese vase dropped off a shelf, fell to the floor, and smashed into smithereens, and released a huge flood of water. Pauli was thinking about Robert Fludd at the time, and he thought, oh no, I've caused this. I'm thinking about Robert Fludd, and through my mental energy, I've caused a flood. So he was it's funny, he was so skeptical about some ideas in physics, but he really bought into the Jungian stuff, at least for a time, and really thought that he had some kind of synchronous connection with the water spilling. Luckily, the Jung Institute remained intact. Nothing happened. It didn't burn down. And I had the pleasure about exactly 1 year ago of visiting the Jung Institute and also his house, which is down the road, which I highly recommend visiting if you're ever in the Zurich area. They have scheduled tours of Jung's house where he met with Pauli and so many others. Their correspondence continued until around 1957, And Pauli became more skeptical. He wrote to J.B. Rhine, who's an American researcher who was researching so-called paranormal phenomena, expressing doubts. Rhine didn't get the letter, though, until after Pauli died. Pauli met an untimely death in 1958, and he attributed some significance to the hospital room where he died, room 137, which is a number of significance in particle physics. And that final year of Pauli's life, he wasn't really corresponding with Jung anymore. He had apparently become more skeptical about whether or not these ideas are correct. So in conclusion, what we might learn from synchronicity is that acausal connections, such as the quantum entanglement, are very important in science. So Jung and Pauli were right there, that perhaps we need to come up with more of a principle, a causal connecting principle like synchronicity to explain all these connections. But then the question arises, why are some links in nature causal and some acausal? Which is more fundamental, or are they on equal footing? Can you explain the acausal events through causality? Or conversely, can you explain causality through acausal events and sheer chance? So people are trying to do that in theoretical physics articles. Now, coincidences in people's lives, on the other hand, we can attribute to sheer chance and the brain's penchant for finding patterns. People get attuned to patterns. So if you are a strong believer in synchronicity in the sense that coincidences are meaningful, you might be looking out for such things. So you might be looking for certain numbers, looking for certain patterns, and you might find them. So things that happen that might be very likely, we might think are improbable. Like, for example, the birthday paradox, that if more than 23 people are in the same room, chances are they share the same, two people share the same birthday, at least two people. So we must apply statistical analysis to any claim with a large sample size, not just go on, what people say. So modern psychology tries to look at large sample sizes, and anecdotal evidence is not taken that seriously just because someone says something. So if you find yourself on a train, superconducting magnetic levitation train that operates on the basis of quantum entanglement, after having a dream about trains, you should thank synchronicity for the propulsion system, which is actually due to electrons moving in lockstep through entanglement, not just a coincidence that you're dreaming about trains and you're on a train. So I'm going to stop here, except for questions. For more about cosmic connections, please check out my book. It's available bookstores, online, in person with a mask. Please frequent your independent booksellers, or you can go online to there are various independent bookstore sites. And of course, the book is on Amazon.com, BarnesandNoble.com, and many bookstores in the DC area and all over the country. So I'm going to stop here. And
all right. Thank you, Paul.
Questions.
Yes. Please do post your questions in the chat window next to the YouTube display. I guess I'll start off with one of mine, and that is from time to time you hear people wondering if we might be living in a simulation. The simulation hypothesis. Neil deGrasse Tyson, for instance, sometimes brings this up, and it can be whimsical, or it might be, hey, how would we test this? And I wonder if synchronicity has been explored in the context of this simulation hypothesis, and I'm overstating the rating of a simulation hypothesis, but is it possible that coincidences that appear acausal are just because of some sort of programming that we're not able to see? I'm just curious if either you have an opinion on that, or if you've seen any sort of discussion of a revisiting of synchronicity in the simulation model.
So to be honest, I don't give much credence to the simulation model, just because it begs the question, what, if we're a simulation, why would there be intelligent beings out there that
Right.
make a simulation? And what if they're simulated too? Why wouldn't they be simulated? And I don't really see anything, in the world that gives evidence of planning, of, if, Occam's razor says rule out everything else, before you look at very far-fetched ideas. So
Right.
I think you would have to have something that would show a glitch in a simulation. If suddenly if suddenly a person froze and there was no explanation for why they froze in place or something, then you're like, okay, well, maybe the programmers messed up there.
Mm-hmm.
But I don't really see any evidence. I mean, I haven't read enough about it, obviously, but something I can read about. But because I haven't really believed that, I really feel like nature is nature. That it seems nature is wild. Nature seems. There's certain aspects that are predictable and certain aspects that seem unpredictable, and I never really felt like everything is programmed. But if it were programmed, I would imagine, just taking that point of view, if everything were programmed and then things came up that were unexpected, you might say, well, maybe that's a glitch in the programming or a flaw in the programming that, it's like the idea, an older idea, which dates back to people like Nietzsche, Friedrich Nietzsche and others, is the idea of eternal return, that everything repeats itself again and again, and that we're just part of many, many cycles. And that's a little bit like the simulation hypothesis, because everything has to repeat itself, so everything is pre-programmed in a way.
Mm-hmm.
But then I read a book once, it's a little far-fetched, that said that the feeling of deja vu is a flaw in the cycle, where all of a sudden you realize that you've done something before because you did it in the previous cycle, whereas normally the cycling is so exact you don't really notice that you've done it before.
Mm-hmm.
So you can come up with things like that. I tend to stay away from things unless there's really some, a bit of evidence, or if something makes theory simpler. Like, I do lend some credence to the concepts of higher dimensions in physics, just because it makes certain ideas in physics a lot simpler.
Mm-hmm.
But it still needs to be tested. But with the simulation hypothesis, I'm not even sure how we could test that.
Okay. One of our viewers has brought up a cultural reference. Chuck Boyce Jr., I assume he's from the Philadelphia area or Eastern Pennsylvania, since he appears to be an Eagles fan. He reminds us of the Police album from 1983, Synchronicity, and I guess there's a couple tracks on there that apparently deal with the topic. And just any sort of comment about that particular album or the tracks?
Well, that's a brilliant album. That's actually my favorite Police album. And writing the book, sometimes the songs from that album, particularly Synchronicity 1 and Synchronicity 2,
Mm-hmm.
went through my head. I was hoping, I had this wild idea of interviewing Sting, why he wrote the album, because he read books by Jung, and even more so, he read books by Arthur Koestler, who talked about synchronicity in a book. I think the book was called A Ghost in the Machine, which is another Police album. And so Sting was very much into philosophy, or maybe he still is into philosophy. But I wasn't able to contact him, but I did get some quotes from him from earlier interviews about his opinion about synchronicity and how that album made an impact on rock music.
Mhm.
and got people tuned into the idea.
Mhm. Mary McCutcheon, I don't know where she's joining us from, has asked about tachyons. Is that something that might involve this action at a distance, or any other aspect that you touched on today?
Well, that's a really good question. So tachyons are a hypothetical type of particle that travel faster than light, but move backward in time. And no one's ever found these, and I thought basically it was a lost cause, but I have a friend, an eminent physicist, Alan Chodos, who's was retired, but now has sort of unretired himself. He's now working at the University of Texas on tachyons. And I interviewed him from the book, and he thinks that there's a chance that these particles, lightweight particles called neutrinos, he thinks that there's a chance that one version of neutrinos could potentially be tachyons. And there was a false alarm a few years ago when scientists in Europe thought that they found neutrinos to move faster than light, and it led to all sorts of faster than light neutrino jokes, and which also mentioned a few in my book. And so I mentioned the idea of tachyons in my book, and interview, as I said, this researcher who's exploring the concepts. And that could, if tachyons exist, then the law of cause and effect could be subverted and run backward.
Okay. We have a question here about whether synchronicity is still being looked into in our modern times, or is this now a relic of Jung's and Pauli's time?
Well, Jungian, there still are many Jungian psychotherapists out there and Jungian analysts. And as I mentioned, the Jung Institute is still around, and there are Jung Institutes in the United States and other places. So they talk about Jung's ideas about synchronicity. Physicists don't generally use the term. I mean, I use the term in my book because I wanted to broaden it and look at the connection between physics and psychology and philosophy. I could have called the book Entanglement, which is more of the term used in physics, but I wanted to be a little different and connect up with psychology and philosophy. But, as a rule, it's the psychologists who mention the term synchronicity, and physicists for acausal connections use the term entanglement.
Mm-hmm. By the way, you mentioned briefly about counter Earth, the Pythagoreans believing that there was another Earth on the other side of the sun. And then you said, so far as we know, there is no counter Earth. And of course, I think you meant something stronger. As far as we know, we're certain there is no such world, both from observation of that part of the solar system and from physics of how the orbit would eventually drift. So
yeah, I was maybe being a little tongue-in-cheek there. Right?
yes.
I was thinking, whenever I talk about counter Earth, I think of a very strange movie. I haven't even seen the whole movie. It's a B movie from the 1950s called Planet on the Far Side of the Sun.
Oh, yeah.
Oh, you've seen it?
Oh, yes.
And astronomers, they go around the sun and like, oh, there's a counter Earth here that we didn't even know about, and everything's reversed. But but no, there's no counter Earth. Obviously, I should have said something stronger, that there's definitely no counter Earth.
Hey, before I get back to our listeners, viewers' questions, a quick one for me. I saw your interview with Michael Shermer, and you mentioned on there that obviously you're a physicist and your wife's a psychologist, which sort of mirrors this topic of, psychologist Jung and physicist Pauli. I'm wondering, did you see any sort of parallel in your own personal life looking at this pair of, explorers, I guess you'd say?
Well, I should add to that, my father's a Freudian psychologist.
Okay.
A retired Freudian psychologist. And my wife is trained as an experimental developmental psychologist. So she has a very hard-headed, very exact approach to psychology and so a lot of the stuff that I say about the need for testing, the need for statistics, that's really what I learned from her, because when she was working on her PhD, she was very exact about statistical models, doing experiments, changing experiments around to make sure that you account for any possible variables. So I saw what she was doing, how exact it was to produce her papers. And then, she would tell me about the old-fashioned type of psychology where people would say, oh yeah, a patient I had dreamed this, so maybe this is right. And she personally is very skeptical about psychology that's done just through personal anecdote, and believes only in things that are done through multiple testing. So I've picked up that idea, and but then when I talk to my father, he had years of experience as a school psychologist, so he'll talk about his personal impressions and so forth, which is a altogether different kind of psychology.
Someone named Jack Musser is asked whether synchronicity is merely a word without real content, just a mystical idea. Would you say it? I mean, obviously Pauli and Jung were trying to attack this in a scientific way. By the way, I really like the contrast between today's talk and our last one about scientifically investigating ghost stories. We're watching two stars in their fields try to probe the edge of the known and the unknown as best they could. And so would you consider this to have been an authentic scientific exploration, or was it just mysticism dressed up in sort of scientific language?
Well, no, as I mentioned in the talk, I think that Jung hit the nail on the head when he was talking about the need for explanation of acausal connections in science. But if he wanted to explore acausal connections in psychology, and we should remain open to that, but you would need massive testing with many subjects and so forth, that kind of work. But in my view, and once again, the reason I named my book Synchronicity is because I think it's an age-old question that dates back to the ancient Greeks, and a question that's still worth exploring. Why are some phenomena in the universe causal and take place at the speed of light or less or slower, and then other phenomena seem to happen instantaneously and aren't acausal? And you can call it synchronicity, you can call it entanglement, you can call it acausal connections. Whatever you call it, these are real phenomena in nature and worth investigating.
Regarding quantum entanglement, you talked about separating two particles and then you observe the spin up or down of one of them. Is that potentially a method of fast communication by controlling the up or down spin of your electron so that the one at the other location has sort of a known response to what you've done to your electron?
Well, there's this idea of quantum teleportation.
Yeah.
But so far, so the thing is, so far people have not found, I'm not completely ruling it out, but people so far have not found a way to convey information using entanglement. And some physicists believed it would be impossible to convey information using entanglement. And the reason is, when you measure one of the particles, there is a 50-50 chance it would be one value. So it's not like you can say, okay, I'm sending a message up, meaning yes, and no, meaning down. You don't know what that's going to say, and therefore you can't actually tell someone who's at the other end measuring the other particle what you're thinking, or send them a series of ones and zeros which can make up a message that way. But that said, there are quantum computers that, although they do not circumvent light speed, they use the richness of quantum information to operate much quicker than ordinary computers. So quantum computers and quantum information are a way of really pushing the boundaries. And that said, perhaps, I should never say never, that perhaps someday someone will find a way to convey information using entanglement. It's not clear that it's absolutely impossible. It just seems impossible according to current ideas.
Mm-hmm. One of our questions here is whether you would speak more on the details about so-called important numbers to physics, such as 137.
Okay, so 137, if you take the inverse of it, 1 over 137, that's very close to a constant in physics called the fine structure constant, which basically tells you the strength of electric and magnetic connections between particles, how they relate to each other. And because it's so close to 1 over 137, a number of physicists over the years, starting with the physicist Arthur Eddington, and then later a physicist named Paul Dirac, became obsessed with the idea that there should be a reason in nature for that. And Dirac, for example, came up with the large number hypothesis, where these large numbers in nature somehow relate to each other and cancel out and give you these constants. And it's kind of interesting. It's in a way numerology, but serious physicists did believe in trying to understand where these numbers come from.
You mentioned lower numbers like 4 and 10, but of course those come up so frequently every day. 137 seems much more unique.
Yeah, well, 4 is important in, for example, in quantum physics, there are 4 kinds of mathematical objects that can explain certain types of quantum interactions. And, they're called the Pauli matrices. So 4 comes up a lot, and 2 comes up a lot because of symmetry. So I guess 4 and 2 are important because of various symmetries.
Humanity has such a good intuitive grasp of some physical phenomena, obviously gravity, dropping something, also to some extent with electromagnetism, in our everyday lives, lightning and so on. But it seemed to me like the quantum world was so unfamiliar, so non-intuitive, that it was a naturally fertile ground for trying to explain maybe paranormal things. Do you have a similar perspective? I don't know if you find that valid. And if so, if we might have future fertile grounds that we obviously, who can envision, future physics, but I just want to throw that concept out there for you to consider.
Oh yeah, well, if you look at history of ideas about the connection between science and the paranormal, believers in the paranormal always try to look for the hidden corners in physics, lurking in physics. So even Newton, who came up with this very deterministic model of how planets revolve around the sun and so forth, said, well, I believe that, miracles can happen, and that perhaps the original positions of the planets, so that Earth is in such a good position, so that it's habitable, has to do with, divine will. And Newton didn't exclude the idea of miracles. And there are many scientists over the years who believe that miracles can happen at some point. Now, with deterministic physics, though, once the physics community got very serious about it, then they start to say, well, maybe everything is predictable. And that's where psychic determinism comes in. And a physicist named Laplace came up with Laplacian determinism, that if you know the situation at one point in time, every situation in time, you can predict the entire universe. Well, then where do ghosts fit in? Where is the spooky stuff fit in? Well, the believers in the paranormal then start to look to other things, like, for example, when the idea of an ether was introduced in the 19th century, something that fills up the vacuum. X-rays had that spooky quality to them when they were first discovered. So you have and you have things called spirit photographs, which are supposedly representations of the spirit, but are just overexposures.
Mhm.
And then the fourth dimension, and then the fifth dimension. Once the fourth dimension was equated with time, then the fifth dimension became associated with spooky things.
Mhm.
And finally, quantum physics has all these open areas, so people have associated that with spooky things.
Mhm. Dark energy is a newer concept that's being explored. It seems to me, I wonder if paranormalists have tried to tap into that. It's at such a great scale, galactic distances and so on. I assume it just doesn't have any practical application for a haunted house or something. But are you familiar with any sort of like dark energy paranormal?
Well, if it doesn't exist, someone should invent it and make a profit out of it, right?
Uh-oh, I may have planted a mimetic
You can
seed here I don't want to
give you
grow.
another job, selling dark energy cures or something like that.
That's right. By the way, speaking of great distances, are there any wonderful experiments that we might be able to do in like 50 or 100 years if we can put an experimental apparatus, at opposite ends of the solar system, or even, partway to the nearest star or something like that, that you would find very interesting?
Well, a lot of people are trying to look for coincidences or connections in what's called, you probably noticed, it's CMB, or cosmic microwave backgrounds, to try to look for examples of entanglement and so forth.
Mm-hmm.
So people are looking backward in time, out into space, trying to look for examples of entanglement on a grander and grander scale.
Mm-hmm.
So I talked to another interview I did recently was with Brian Keating, who is a astrophysicist, who mentioned he had a connection with those kinds of experiments.
Mm-hmm.
So they're called quantum bell tests. A bell test is something that determines whether or not entanglement is real. So there are a lot of interesting things going on in terms of setting up craft in the opposite sides of the solar system, and then trying to do entanglement that way. I'm sure if that's possible, some people will think about that at some point.
Mm-hmm.
People seem to be coming up with every possible variation of entanglement and teleportation experiments.
Mm-hmm. Paul, may I bring up the coincidence that you and I experienced just a couple of days ago? I mentioned I work at Goddard Space Flight Center, and you knew a recent alum of your university that started there not too long ago. And I didn't recognize her name. I don't know her. And then I guess to see if I had a connection, you mentioned who her grandfather is, and he was at the University of Maryland, which is where I went, as you knew. And the name didn't just ring a bell, but it was a coincidence. He was the previous occupant of my mother's apartment at a retirement community here in the Washington area. It has about 2,500 residents, so it's not a small community. But anyway, Stephen Brush is, I guess, a professor emeritus of history of science, I think, or philosophy. He certainly worked in the history of science, and he happened to be the prior occupant of my mother's apartment and the grandfather of a student that's at Goddard right now.
Right. Plus, he was an honorary alumnus of U Sciences when that student, Jennifer Dimov, graduated, formerly Jennifer Roberts.
Yes. And of course, there's so many facts around us. We should expect occasional random overlaps. I think you and I just experienced. It doesn't necessarily have.
Well, when I took her on as a student, she was my research student.
Oh.
And she mentioned that her grandfather was a physicist. And at that time, I knew Stephen Brush because I was involved in helping him be awarded the Pies Prize, which is a prize for the history of physics.
Mm-hmm.
I was actually on the committee that awarded him a prize.
Mm-hmm.
So I known him through that context. I guess I've lived long enough to realize there are times when there are these stunning coincidences, but then if you look for them, sometimes they don't happen. And I guess because I've had some amazing coincidences, but then other times when just things are ho-hum, pretty bland, I just think, well, eventually there are going to be coincidences. I guess I'm pretty zen about that. I just think, well, coincidences happen. They happen sometimes. I don't get too shocked by things like that.
I wonder, did Jung and Pauli try to categorize coincidences? Some of them just being mundane, random overlaps is, I think, the one that you and I just discussed it for ourselves, and maybe ones that are remarkable or somehow special. Did they try to categorize?
I think anything coincidence Jung cared to talk about, he thought was special, just from his own philosophy. But, I'm sure, like, if, I don't know, he was in a restaurant and two people dropped a fork at the same time, or something just really mundane happened at the same time, it wouldn't really, probably something very, very mundane, he might just think, oh, that's sheer chance. I don't know if he would really, obsess about it. Now, if he was at a restaurant and someone was talking about forked time and then someone dropped a fork, another person dropped a fork, then he would write it down and put it in one of his books.
I see.
But I guess I've had some pretty big coincidences. I actually had an interesting coincidence while writing the book that if I was more spiritual, I would attribute to spiritual synchronicity. So here's the coincidence that happened while I was writing the book. I was writing the book in a coffee shop, and I just started working on the beginning of the book, which has to do with ancient Greek ideas. And then I overheard a woman in the coffee shop, slightly older woman, talk about ancient Greeks. And I introduced myself, and she turned out to be a Jungian analyst, but also really obsessed with ancient Greek imagery and Gnostic imagery, meaning a group of Christians that believed in mysticism and hermetic ideas and all this mystical stuff. So, and the at that time, the coffee shop was about to close. So I said, do you have any references to your work? And she wrote all this stuff down on a napkin and she gave me her email address and said, here's some references. This is exciting. Let me give you some ideas. And I emailed her once and didn't really get much of a response. And then I almost forgot about her. And then the very last day I was finishing the manuscript, I came back to the same coffee shop, which I went to pretty regularly, but it was the last day. The last hour it was open, it was about to close. And I just finished up the first draft of the manuscript. And I'd written about the part about quantum physics, modern quantum physics. And then all of a sudden she walks up to me. It's the second time I saw her. She says, oh, aren't you the guy who's writing a book about synchronicity? I said, yes. I said, I just finished it. She said, oh, wow, that's exciting. And I said, well, I was just writing about quantum entanglement and stuff like that. And she said, oh, well, my late husband knew David Bohm and knew all these people in quantum entanglement too, and she had a connection with the quantum physics too. And then I said, well, good talking to you. And she said, well, I have to run now. This is my last day in the Philadelphia area. I'm moving to the Southwest. This is my last day in the coffee shop because I'm moving. It's great that we ran into each other again. And that hit me as being a pretty odd coincidence that I would see her in her very last day in Philadelphia. And it was my last day writing the book, and that she had all these connections. But but other people would say, well, things like that happen.
Yes. Yeah, my personal feeling is to appreciate the beauty of something, even if it's just a random, mundane overlap. I like it. Sometimes it makes me laugh. It's just a funny thing. just like ours that we just discussed.
Well, the thing I like about skeptics groups is skeptics groups don't just say, well, we're dismissing all this stuff. Skeptic groups, my impression is, look at things in an analytical way and try to weigh the evidence and try to remain open-minded. And that's my philosophy in life too, is I never dismiss people. I never dismiss ideas. I might say, if somebody says, if somebody says like they have, well, I've traveled to other dimensions in my dreams and I've traveled to other planets in my dreams, I'll say, oh, that's interesting. But I would never say, that's crazy or something like that. But then if they ask me, well, what does physics say about traveling to other planets in your dreams? I'll say, well, actually physics does not address that and does not, as a scientist, I would not believe that that's possible. And leave it at that.
Yeah, as you probably know, there are people that, claim that they can do these journeys, and sometimes they're asked, hey, what does it look like in the atmosphere of Jupiter and so on? And it turns out that they were wrong, as when we were able to actually explore those places with sensors. So some skeptics would pose some tough questions for these alleged explorers, I guess. And so extraordinary claims require extraordinary evidence, as Carl Sagan famously said. Let's see, looking back to our questions here. Let's see, someone named Desi Ray has asked about so-called scary coincidences. By that, I assume ones that aren't mundane, but actually like deeply meaningful. Are you familiar with any that are just like, wow, that's life and death? That's something where if somebody hadn't done something, the world would have changed, something like that.
Well, I do talk in my book about the need for pattern recognition as a matter of survival, a survival skill.
Yeah.
So I think the brain started recognizing patterns, evolved to do so because it gives us an advantage. As if we hear the sounds, we're out in the plains of Africa, and we hear sounds of a wild animal coming, or or if we're on a highway and we start seeing flashing lights in the corner of our eyes, we're going to make a connection and immediately get out of the way. And but the problem is we're so attuned to that we might start making connections that are invalid and start believing in them. So if every time, if you didn't know that thunder and lightning are connected, and every time you see lightning, then you hear the sound of thunder shortly thereafter, you might correctly conclude, as I say in my book, that lightning and thunder are related phenomena. But if every time you see a flash of lightning, something terrible happens that has nothing to do with the lightning. So for example, you see a flash of lightning, and then a friend of yours says, oh, I'm really starting to feel ill. And then another time you see a flash of lightning, and it just happens to be a day that the stock market doesn't do very well and you lose money investing. And then you say, well, there's a connection between lightning and bad omens, and that lightning is a portent of something bad is about to happen. Well, that would be making an unreasonable judgment, and statistics would bear out that there's no connection between lightning and ill fate, except people who are out in a storm and get hurt during the storm.
As one of our participants says, correlation does not equal causation.
Yeah, so you absolutely have to analyze things statistically. I don't have a background in statistics, unfortunately, but I learned enough in writing the book to know that there are spurious correlations. There are correlations that are based upon a common factor, or which need in any experiment kind of need to be ruled out. So and then there are real connections that might, if you discover them, might actually change the course of science.
Mhm.
We have to keep open to the possibility that some connections are real, even though many connections are just chance happenings.
Let's see, it looks like we might be wrapping up here. Paul, any last comments? I guess if everyone will join me in thanking you for spending time with us today, and hoping you stay safe. And I'll mention that we'll be on again next month, Saturday, November 14 at 1:30 p.m. Eastern Standard Time. That's 1830 GMT. Caitlin Ahrens, a planetary scientist at NASA's Goddard Space Flight Center, will present In a World, a Hollywood View of Planets. Venture across fascinating planetary landscapes, first in Hollywood films and then in NASA images. That's November 14 at 1:30 p.m. Eastern Standard Time. And thanks to JD Mack for producing today's program. Stay safe, everyone, and join us next time. Bye-bye.
Bye-bye.